Alright, welcome to the second video in the Leaving Cert probability series, where we're going to look again at counting outcomes for given experiments. As a first example, we'll look again at a coin toss, but a slightly more complex example. So in this coin flip experiment, we're going to flip the coin twice, and this is a place where a tree diagram is particularly helpful. So say at the start we have the coin unflipped, technically neither heads nor tails, and then when we flip it, it lands on either one of two options, heads or tails. As we saw before, that's the first toss, and they're the only two possible outcomes when we're using a fair coin. So then if we were to flip the coin again, so say for the sake of argument we landed on tails first on the first toss, then the coin has no bias still. It's still a 50% 50-50 coin, heads or tails. So the next two possible outcomes after tails are going to be heads or tails again. And similarly, if we had landed on heads first, the same two outcomes are possible, H or T. And just as a side note, you could continue this. You could say H, then H or T, then T, then H or T. But we're not going to look at that at the moment. So what we are going to look at is each one of these individual routes. So from the start, if we go along this route where we get heads first and then heads after that, that's one possible outcome. H, then H is one possible outcome. And then similarly, if we were to land on, say, heads again and then tails, that's another possible outcome. And also, I think you'll get the picture, like so tails, then heads, or tails, then tails. So that's for the second toss. And that gives us all the information we need to know for our sample space. So we'll see that next. So each one of these branches are separate outcomes, and we can write out each outcome in the form of, say, H for this branch, or TH for that branch, or HT or TT, and then we can write our sample space. So these are actually the elements of our sample space. These are the outcomes. So if we do S again for sample space, so one element is going to be H, corresponds to that branch, and then the next element is going to be HT, and these are not necessarily in order. These are just all individual roots. And then TH and TT. So that's the sample space for this coin toss experiment where you toss the coin twice. So another way of representing the possible outcomes of a given experiment is to use an outcome table. So here we're using it for the coin flip experiment again. So on the rows we have the first event, which would be our first coin flip, and the possible outcomes are going to be heads or tails. And then the second on the columns are going to be heads and tails as well. So when we match these up with each other, we get H, heads, tails, tails, heads, and tails, tails. And these are the possible outcomes. So each one of these boxes is an element of the sample space. So let's look at another quick example. So this table here is for a coin toss and a die roll. So here on the rows we have the possibilities for the outcomes for the coin toss, and then on the columns we have the dice possible outcomes. So one of our possible outcomes will be, say, if the coin is a head, then the next could be either a 1, 2, 3, 4, 5, or 6. But here in this column we have a 1. And then H, 2, 3. So there are the possible outcomes if the first flip of the coin lands on heads. The next possible outcomes are that the coin will flip and land on tails, and then we get a 1 in the dice, or a 2 in the dice, 3, 4, and 6. So they are the possible outcomes for a coin toss and a dice roll. So it's worth noting that we can count the individual outcomes here in the boxes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. And it'll be interesting to see this on a tree diagram as a visual aid. So here we are at the start, coin isn't flipped, and then it goes either heads or tails. And then we're into the dice roll. So there's 6 possibilities, there's 6 outcomes of a dice roll. It can be either 1, 2, 3, 4, 5 or 6. And then each branch, as we had seen before, leads to an individual outcome. So heads and then 1 is a possible outcome. Or heads and 2, heads and 3, 4, 5, 6. So on this side, there are 6 possible outcomes. And then on the tail side, where if the coin flip leads to tails, there's going to be again 6 possible outcomes for the dice. So altogether, there's going to be 12 possible outcomes. So that is the tree diagram for the experiment, and next we're going to look at the fundamental principle of counting. So I think I might actually do that in a new video. So thanks for watching, and hopefully it was helpful.